So we're going to take a look at a couple of examples where we're given a word problem and we want to translate the context of the problem into a formula so that we can use that formula to evaluate the function at different points. So let's take a look at page 77 as 6. In this example, we're told that we want to rent a special area in a restaurant, and it's going to cost us $500 to rent that space. In addition to paying $500, we also have to pay $10 for every guest that we invite. So we want to take a look at how to write a formula that gives us the total cost, which we'll call C, as a function of the number of guests that we invite. So we want to write a formula to calculate total cost when we know how many dinner guests there are. So in this particular problem, they've already given us the variables. They've labeled it C and N, but if that's not given to you, then you want to actually label your variables yourself. But an important phrase in this problem is that phrase as a function of. So if you recall back in section 1.1, we talked about how important this phrase is. And because this phrase helps us define the function, but it also tells us which variable is the dependent variable and which variable is the independent variable. But I think that you could probably already figure out which variable depends on what. So in this problem, it makes sense that total cost would depend on the number of guests that we have and not the other way around. But if you're not sure which one is the independent and which one's the dependent variable, look for this phrase as a function of and recall that whatever variable is in front of that phrase, this is always your dependent variable. Okay? And then whichever variable follows that phrase, so the variable that is after this phrase, which here is n, this is always your independent variable. So in this problem, C is a function of n. C depends on n. And as soon as I figure out which one is the dependent and the independent variable, I always like to sketch myself a quick graph so I can label the variables on it, and it kind of helps me keep track of which one is the y, so which one's on the y-axis and which one's on the x-axis. So here, since C is the dependent variable, that's going to go on the y-axis, so that's C. If you want to practice writing function notation, this function, we can define it as C of n, okay, where C is the total cost measured in dollars, okay? And then our x-axis here, this is going to be n, where n is the number of guests. Okay. Now before I start writing the actual formula, right, it might be helpful for us to work out a couple of small examples based on the information that's given to us to see if we can find a pattern, because patterns are what gives us the formula for the function. So the formula comes from the patterns that we see. So in this particular problem, let's work out, let's make this a little bit straighter. Let's try to calculate the total cost when we have a certain number of guests who are invited. So let's suppose that we invite one guest, okay? What would our total cost be if we invite one guest? Well, we know that it's $10 a guest, so that would cost us $10 for that guest. But then we still have to pay for the venue, so that's another $500, which means that the total cost for inviting one guest would be $510. Okay. Now, what if we were to invite two guests? How would we calculate the total cost? Well, again, we know that it's $10 per person, but there are two people, so that must be 10 times 2, which is 20. Right? But then we still have to pay for the venue, so that's another $500, which gives us $520. We can keep going until we see a pattern. Let's take it out to 3 guests. If we invite 3 guests, what is our total cost? So again, it costs us $10 per guest, and we've got 3 guests, so that's $30, but we still have to pay that $500 for the venue, so that gives us a total cost of $530. Now, we can keep going, but I think that this is enough information to help us find the pattern that will lead to the formula. So when you take a look at the work that you've done here, pay attention to any patterns that you see. And usually what I do is I go through and I see what's similar in each step and what changed. So what varied. So if we take a look at this problem, and I'm going to rewrite this here, 10, this is the same thing as 10 times 1. Okay, so if we go through this problem, notice that when we calculated the total cost, what changed was this number here. So every time this changed, all right? And it just happens to be that this number here inside the parentheses is the same thing as n. So therefore, I can replace this to come up with a general formula and replace that with n. Now, what stayed the same? So throughout each step to calculate the total cost, 10 was the same, right? The 500 was the same. The plus sign was constant. And then also this multiplication of the variable cost, right? 10 times n. So now that really helps me write the formula. So I see that to calculate c of n, right, or that's the same thing as saying c. So to calculate the total cost, c, I have to take $10 and multiply it by n, which is the number of guests, and then add my cost of $500 for the venue, and that gives me the total cost. So notice that this pattern helps us come up with the formula. So now that we have the formula, we can actually evaluate the formula to get a table of values. And you can actually just use some of the numbers that you've worked out in the example here to get your table. Or you can actually use your graphing calculator to get your table of values, and I'll actually show you how to do that in Chapter 2. But here, if I wanted to create a table just so I have a few points so I can graph it, right, let's go ahead and put in a few points just to give us enough to graph. So when n is 1, when n is 2, when n is 3, and I'm skip counting by 1, but you can skip count by whatever you'd like. So no guests show up, the cost is 500. One guest shows up, it's 510. 2 guests show up, 520. 3 guests show up, 530, etc. Okay, and we can start making a rough sketch of this. So when n is 0, let's say that that's 500. Okay, when n is 1, 2, 3. So when n is 1, let's say that's 510. When n is 2, that's 520. When n is 3, oops, let me replot that up here. Okay. When n is 3, we get cost is 530. And this gives us a general idea of what the graph looks like. And let's see if I can connect these points. I cannot do this very well on the computer. I hope you get the general idea when I connect those points. I get a nice line that shows the pattern of what's going on in this problem.